Continuous integration and continuous delivery are nowadays staples to building production-grade real-world software, but they are often associated with clunky and hard-to-set-up build servers and complicated workflows. So today, we're going to have a look at how we can easily set up a fully functional CD/CI pipeline for any Firebase project using GitHub Actions. Our journey begins in the Firebase console. From there, we select Add Project. We give our new project a name, click through the instructions, and then wait a while for the setup to complete. Then we open up a terminal and run the following commands to install the latest version of the Firebase CLI and log into it, if we haven't done that already. Now we can create a new directory, navigate into it, and then run Firebase init. When we're asked which components we want to initialize, we select everything except for the emulators, because we won't be needing them in this video. Now in the project setup phase, we choose to use an existing project, and then we link it to the one that we just created. For all other initialization options, we're just going to stick to the default ones provided by Firebase. Now we can open up the project from our favorite editor and have a look at what the CLI has generated for us. Starting from bottom to top, we have a couple of rules files, some index files, a Firebase JSON file containing the information for our project, a public directory which contains the code for the Firebase hosting component, and finally the functions folder, which houses the logic for, you guessed it, the Firebase functions. With that in mind, we now want to set up our project as an NPM package, and we do that by running npm init-y. Now we can go in our package.json file, clean it up, and add the following scripts to it. Since the functions component has dependencies which are needed for its build script, we add a root level install script and trigger it in the post install hook. We do this in the package.json because it's subjectively a lot cleaner than having to execute said scripts in the pipeline. With all that done, we can start preparing our project for GitHub by initializing it as a Git repository, staging our files, and creating our first commit. Then we jump into the browser again, this time opening up our GitHub account. Click on New, give our repo a name, press Create Repo, and execute these commands in a terminal in order to push our code to the GitHub remote. Finally, we can get into the meat of the story, GitHub Actions. With it, you can automate virtually every aspect of your software development's workflow. You can build, test, package, release, deploy, all from the comfort of your repository. And with its extremely generous pricing tiers, most users won't have to pay a dime to use it. The way you use GitHub Actions is as follows. You create a .yaml file in the .github/workflows directory of your project. You specify the commands you want executed and under which circumstances you want them to execute. Then you commit and push your code. And basically that's it. Simple, isn't it? Now let's have a look at what makes a typical workflow file tick. It has a name, the events for which the workflow executes. In this case, it gets executed whenever a commit gets pushed or a pull request gets opened for the master branch. There are also the workflow jobs, which can run sequentially or at the same time. In this case, only a build job is present and its components are the environment in which it runs, Ubuntu latest, and the steps it consists of. You can think of a step as a standalone unit of work, which can be a single terminal command or an aptly named action. Like for example, the checkout action, which loads the latest version of our repository into the workflow container. What's cool about actions is that they're just GitHub repos that you can check out and modify to your liking. And as luck would have it, there's an abundance of actions in the GitHub marketplace. Now, armed with all this knowledge, let's proceed to creating our own workflow. We do that by going to the Actions tab of our repository and clicking on Set up a workflow yourself. Now we can give both our YAML file and workflow a name, specify that the workflow will get triggered on every push event to the master branch. Then we add our build and deploy job, give it a name, and specify its running environment. Now we add our steps. First off, we clone the latest version of our repo in the container. Then we install our dependencies, which, if you remember, triggers the dependency installation of our functions subproject as well. And finally, we deploy our app via the following third-party action, which is basically a wrapper of the Firebase CLI. This action requires a Firebase token environment variable, so let's provide it with one. Let's hop back into the terminal and run Firebase Login :CI. Copy the generated token, click on Secrets in the Settings tab of our repo, select Add a new secret, give it a name, and paste our token. With all that work done, our workflow is finally ready for action. We can now click on Start Commit and Commit New File. Then if we head into our Actions tab again, we can see that the workflow we just created is currently being executed. When it's done, we can head on into our Firebase console, and lo and behold, the deployment was a success. Bonus tip number 1. You can enable email notifications for GitHub Actions so that you can instantly feel the joy or sorrow that come with a passing or failing workflow. Bonus tip number 2. You can create a status badge, add it to the project's README, because all the cool open source projects have them too. With that, you're now officially a certified senior DevOps engineer. Congrats! That's all I have for you in this one. If you have any recommendations on a topic I should cover in the next video, be sure to leave a comment. Thanks for watching, and I'll see you next time.